Today we are talking about radians, coterminal angles, and a brief little discussion on sectors. Okay, so measuring angles. Angles can be measured using two different units, degrees and radians. They are just two different measurements for angles. Just like you can measure distance in feet or inches or miles or meters or centimeters or whatever, distance can be measured in different units. Measuring angles, two different units, degrees and radians. Okay? Radian units, even though right now you're more comfortable with degrees, radian units are more convenient for numerous reasons. In calculus, we use radians exclusively. Our derivative and integral rules are only valid if the angle is in radians. So, everything that we do in calculus is radians. So, because of that, this is what we're going to be using in pre-calculus, because we're getting you ready for calculus. Alrighty? So, I need you to get very comfortable with radian units. Okay? Like I said, I understand. Right now you know degrees more. I know if I asked you where 90 degrees was, you would know exactly where that was. If I asked you where 7 pi over 6 is, you may not know where that is yet, but you will. You need to. Okay? Radians. Alrighty. A definition for us. An angle is said to be in standard position if it has its initial ray, its initial side, at 0 radians. So this is the initial side of every angle in standard position. So I would like for us to think of all of our angles as starting right here. Okay? The terminal side can be anywhere. It can be in any quadrant, whatever. Okay? If we're going counterclockwise to get to the terminal side, then that produces a positive angle measurement. Okay, if we're going in the opposite direction to get to our terminal side, let's say that we're ending right here. If we're going clockwise to get to our terminal side, that angle will be negative. Okay? So to get to this terminal side right here, we could go all the way around this way, or we could go backwards to get to it. Okay? Alright, so because I know right now that you're more comfortable with degrees and radians, let's learn a way to convert from degrees to radians or radians to degrees. Okay? So to convert between radians and degrees, we use this conversion factor. This is our conversion factor. Pi radians is equal to 180 degrees. Okay? So, let's convert 45 degrees to radians. 45 degrees is how many radians? I know that I'm setting up a proportion. I know that 180 degrees is pi radians. So how many radians is 45 degrees? Do you see how the little degrees cancel? So we're going to be left with radians. I'm going to multiply both sides by pi, and I get 45 pi over 180 is equal to x, which means that x is equal to, how many 45s are in 180? There are 4 of them, so we get pi over 4. So 45 degrees is equal to pi over 4 radians. Now I will tell you something. If you have a degree measure, you must write the degree symbol. If you have a radian measure, you do not have to write radians every time. There's no shortcut for the word radians. Okay, there's this little symbol for degrees, but there's no such symbol for radians. But what I can do is I can say 45 degrees is equal to pi over 4. I don't have to write the word radians, they are assumed. Okay, let's convert pi over 6 radians to degrees. So I'm going to set up another proportion. Pi over 6 is how many degrees? Well, I know that pi is 180 degrees. Make sure you have degrees on one side, radians on the other side. Degrees on one side, radians on the other side. Okay? And now I'm going to cross multiply. Well, not really cross multiply. I'm just going to multiply both sides by the 180 degrees. And I'm going to have 5 pi over 6 divided by pi. Well, dividing by pi is the same as multiplying by 1 over pi. And then I'm multiplying by that 180. Do you see how the pi's cancel? And I'm left with 5 divided by 6 times 180 degrees. How many times does 6 go into 180? Well, 6 goes into 180 30 times. 30 times 5 is 150. So we know that 5 pi over 6 radians is the same as 150 degrees. Okay? So that is how I would convert from degrees to radians or radians to degrees. So again, if you write an angle in measure in degrees, you must use the degree symbol. If you write an angle measure in radians, you do not need to write the word radians afterwards. It is understood. Okay? All right. Since we work exclusively with radians in calculus, you must have a good understanding of how large they are and how they relate to their equivalent degree measurements. Radians do not have to have pi's in them. They often do, but they don't have to. Remember, pi is just a number. Pi is equal to 3.14159 blah, 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 right? That's just a number. It's just a little over 3. Okay? So I know that 180 degrees is pi radians. Yeah? I know that 0 degrees is 0 radians. So if I go all the way to here to get to pi, what would happen if I kept on going and got all the way around back to our starting? What is 360 degrees? If this is pi, what is this? Going all the way around. Well, that would be 2 pi. That's 2 pi, right? But remember, pi is just a number, so this is like 3.14159 blah, 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 blah. 2 pi would be 6.28 blah, 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 yeah? So where is 1? If this is 3.14, how far do we go to get to 1 radian? Which quadrant would that be in? Well, it would be about a third of the way, right? A little less than a third of the way. 60 degrees is a third of the way to 180 degrees, so it would be a little bit less than 60 degrees. Let's find out how many degrees that is. Okay, I'm going to come back over here. 1 radian. I want to know how many degrees. How many degrees is that? Well, I know that pi radians is 180 degrees. So if I multiply both sides by the 180, I get x degrees is 180 degrees divided by pi. And if I put that into my calculator, I can get 180 degrees divided by pi, 57.2957 degrees. Okay? So yeah, a little less than 60. So right here, about right there, is 1 radian. So where is 2 radians? Where's 2 radians? Well, it would be somewhere over here, right? A little less than another third of the way, so a little less than 120 degrees. We can find out how many that is. 2 radians is how many degrees? Pi radians is 180 degrees. So x here will be 2 times 180 is 360 divided by pi. Oops, 360 divided by pi. So x is 114.5915, blah, 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 blah. Okay, so yeah, it's a little less than this 120. There's 2 radians. Okay, so where would 3 radians be? Well, 3 radians would be a little less than 3.14159, yeah? So around there, 3 radians. And we could find out if we wanted to, but I think you get the idea. I need you to know where 1 radian is. I need you to know where 2 radians is, and so forth. Where's 6 radians? Well, a little less than 2 pi, because 2 pi is 6.28-ish, okay? So 6 radians would be a little less than that, yeah? I need you to have a general idea about what is a radian, okay? A radian is about 57 degrees. All right, let's keep on going. Okay, on this next page, we have a blank circle with different rays coming out of it, and I need us to be able to, instead of using degrees, I need you to get very comfortable very quickly with radians, and it's really not hard. Okay, we are going to start at 0 radians. 0 radians. If we go all the way around, we get 2 pi radians. Okay, that's all the way around, 2 pi radians. If we go halfway around, we get pi radians. So what makes it if we go a fourth of the way? What happens if we go only up to here? That's 90 degrees, right? What would that be? Do you agree? 1/2 of pi. 1/2 of pi, I'm going to write that in the simplest way I can and make it pi over 2. That's how you're going to see it all the time. So just think of that as pi over 2. Okay? Let's go down here to 270 degrees. Well, if this is pi and this is 2 pi, what's this? You're like 1.5 pi? 1.5 pi, yeah? Or 3 pi over 2. 3/2 pi. 3 pi over 2. All right. So those are our axes, radian measures. Okay. All right. Let's do the 45 degrees. The 45 degrees is right here, yeah? If this is 0 and this is pi over 2, what is halfway between them? Do you agree? Pi over 4. 1/4 pi, or pi over 4. So what would be the next 45 degree measure in quadrant 2? Well, it's halfway between pi over 2 and pi. So 3/4 pi, or 3 pi over 4. Let me show you another way to think about this. I'm about to sneeze, hang on. Oh. Excuse me. Oh, something is tickling my nose. Alrighty. Let me show you another way to think about this. 0, I don't really want to mark all over this. Maybe I'll do it with, let me pull out. I'm going to pull out one of my erasable pens. Okay. 0 is the same as 0 pi over 4. this is the same as 1 pi over 4. This is the same as 2 pi over 4, because the 2/4 would cancel and get 1/2. This is 3 pi over 4. This is 4 pi over 4. 4 pi over 4, right? The 4 is reduced to get pi. What would the next pi over 4 be? The next pi over 4 would be 5 pi over 4. Then we would hit 6 pi over 4, which reduces to 3 pi over 2. And then we get 7 pi over 4. Okay? And if we keep on going, we'll get 8 pi over 4, which is back to 2 pi. Let me erase these guys. Alrighty. Okay, so those are all of the pi over 4s. Alrighty. Let's go now to, let's do the 60 degrees. 60 degrees. All right. You know what? Let's do the 30 degrees. 30 degrees is 1/6 of 180 degrees, right? 30 degrees is 1/6 of 180 degrees. So what would be 1/6 of pi? Pi over 6. That would be 1/6 of pi. Yeah? If we go to another 30 degrees, we're up to here, yeah? So it's another 1/6 of pi. So it would be 2 pi over 6, but 2 pi over 6 reduces, doesn't it? It reduces to pi over 3. So again, 1 pi over 6, 2 pi over 6, but it reduces to pi over 3. If we go another 30 degrees, we're up here at 3 pi over 6, but that reduces to pi over 2. Here we would hit 4 pi over 6. But what does that reduce to? That reduces to 2 pi over 3. We're going to go another pi over 6. 5 pi over 6. 5 pi over 6. 6 pi over 6 is back to pi. What will be the next one? 7 pi over 6. The next pi over 6 would be 8 pi over 6, but that reduces to 4 pi over 3. The next pi over 6 here would be 9 pi over 6, but that reduces to 3 pi over 2. The next pi over 6 would be 10 pi over 6, but that also reduces to 5 pi over 3. And our last one will be 11 pi over 6. Okay, I'm going to erase these guys again, because I want to do something else with this. Alrighty. So that's just the going around and labeling these. But I need you to know where these are. If I ask you where 7 pi over 6 is, I need you to know right where that thing is. So here's how I do it. Here's how I think of it. If I'm asked for 7 pi over 6, if I'm asked for that, I know that 7 is 1 more than 6, isn't it? If it was 6 over 6 pi, 6 over 6 would be to here. We're going to go 1/6 more. 1/6 more. Quadrant 3. It's that shortest special angle in quadrant 3. Okay? What if it wasn't a 7 pi over 6? What if it was a 5 pi over 6? Well, 6 over 6 would be all the way to pi, right? Well, 5 is 1 less than 6. So it doesn't go all the way to pi, it stops just short. Right there in quadrant 2. What if I wanted 11 pi over 6? Well, 11 is almost 12. And if it was 12 pi over 6, it would be all the way around. But it's not all the way around, it stops just short in quadrant 4. What if I was asked, where is 5 pi over 3? Well, doubling 3 would get me to 6, and 5 is not all the way to 6. So it's not all the way to 2 pi. It's 1 pi over 3 less, and pi over 3 is the bigger angle in quadrant, well, it's a bigger angle, so than pi over 6. So it would be down here in quadrant 4. What if I was asked where 3 pi over 4 is? Well, 3 is almost to 4. 3 is almost to 4. If it was 4, it would be over here to pi. 3 is 1 less. It's the middle angle in quadrant 2. That's how I think of these. Okay? That's how I think of these. All right. Let's talk about coterminal angles. Coterminal angles. When Aunt Vi was walking around her route yesterday, or whenever we did Aunt Vi, okay, she sometimes ended up at the same point, even though she walked for a long time, because she kept on doing the same route over and over and over again, yeah? That same location, that's what coterminal angles are all about. You end up at the same spot. When you go around and around and around, you end up at the same spot, okay? So the initial side of an angle in standard form is always at 0 radians. So that's our starting point. 0 radians is our starting point, or our starting side every time, okay? That's our starting side. The terminal side of the angle is formed by rotating a ray from that initial side. So if my angle is positive, then I go counterclockwise. So if I wanted to go to 7 pi over 6, I would go start here and go around and stop there. Okay? That's 7 pi over 6. Okay? But how else could I get there? So that is 7 pi over 6. Yeah? How else could I get there, though? I could also get there. I could also get there by going this way. And I would still end up at the same spot, right? How many radians is this? I'm going backwards, so I know it's going to be a negative something. How far do I go backwards? Well, not all the way to pi. It's not negative pi. It's negative 5 pi over 6. So 7 pi over 6 and negative 5 pi over 6 are coterminal angles, because you end up at the same spot, okay? There are more coterminal angles with 7 pi over 6, because what else could we do to get there? I could start here, I could go counterclockwise, but go past it and go all the way around. Remember Aunt Vi walking? She could go all the way around and then end there. That would be 7 pi over 6 plus 2 pi. 7 pi over 6 plus 2 pi would get me another coterminal angle with 7 pi over 6 and negative 5 pi over 6. Okay? Graphically, the ending is no different. If I just showed you this and said name that angle, there are an infinite number of answers. If I just said name that angle. If I just said, hey, name that angle, there's an infinite number of answers to that question. Okay? One of them, the most obvious, would be like pi over 4. I'd say, okay, that angle is pi over 4. That's one answer. But I could also say that is negative 7 pi over 4. Or I could say that that answer is pi over 4 plus 2 pi, which would be pi over 4 plus 8 pi over 4, or 9 pi over 4. These are all coterminal. Alrighty. So, to find coterminal angles. To find coterminal angles, you take one of the angles. Usually you're given this angle. Take your angle and add 2 pi to your angle, or subtract 2 pi from your angle. That's how you get all of your coterminal angles, however many you like. Let's find 6 coterminal angles for pi over 3. We're going to make 3 greater than pi over 3 and 3 less than pi over 3. So I'm going to start with pi over 3, and I'm going to begin by adding 2 pi. 2 pi, I got to get a common denominator. 2 pi is 6 pi over 3. 6 pi over 3 plus 1 pi over 3 is 7 pi over 3. We found our first coterminal angle. Now I'm going to take that and add another 2 pi. Aunt Vi is going around and around her route. So we're going to add another 2 pi. 2 pi is 6 pi over 3. 6 pi over 3 plus 7 pi over 3 is 13 pi over 3. Take 13 pi over 3 and add another 2 pi. 6 pi over 3 plus 13 pi over 3 is 19 pi over 3. What are we doing to get from one to another? We're just adding 6 to the numerator. What would be another coterminal angle then? 25 pi over 3. Just keep adding 6 to the numerator because the denominator is 3. Okay, now let's find 3 less than pi over 3. So I'm going to take pi over 3 and subtract 2 pi. So pi over 3 minus 6 pi over 3. Pi over 3 minus 6 pi over 3 is negative 5 pi over 3. Now 5 pi over 3 minus 2 pi. So 5 pi over 3 minus 6 pi over 3. Oops, that's negative. Negative 5 pi over 3 minus 6 pi over 3 is negative 11 pi over 3. Negative 11 pi over 3 minus 2 pi. Negative 11 pi over 3 minus 6 pi over 3 is negative 17 pi over 3. So here each time, what are we doing? We started with pi over 3, we subtracted 6 from the numerator. And then subtract 6 from the numerator, subtract 6 from the numerator. The next one would be a negative 23 pi over 3. So 6 coterminal angles for pi over 3 are 7 pi over 3, 13 pi over 3, 19 pi over 3, negative 5 pi over 3, negative 11 pi over 3, and negative 17 pi over 3. But we could get an infinite number more if we liked. Okay? So let's find 6 coterminal angles for negative pi over 6. We're going to have 3 larger than negative pi over 6 and 3 less than negative pi over 6. So I'm starting with negative pi over 6, and I'm going to add 2 pi. All right, 2 pi. Our common denominator is going to have to be a 6 this time. So 2 pi is going to be 12 pi over 6. 12 pi over 6 minus 1 pi over 6 is 11 pi over 6. Now I'm going to add 2 pi to that. So I'm adding 12 pi over 6. 12 pi over 6 plus 11 pi over 6 is going to be 23 pi over 6, right? I'm going to add another 2 pi. 23 pi over 6 plus 12 pi over 6 is going to be 35 pi over 6. So those are 3 larger than negative pi over 6, 3 coterminal larger than it. So again, what did we do? What's the pattern here? The pattern is we're adding 12 to the numerator. But we can also subtract 2 pi. In this case, we're going to be subtracting 12 pi from the numerator, right? So this will be a negative 13 pi over 6. What will be the next one? We're going to subtract another 12 pi from the numerator, yeah? So that will be a negative 25 pi over 6. Subtract another 12 pi from that numerator, and we're going to get negative 37 pi over 6. Okay, so all of these are coterminal with negative pi over 6. Negative pi over 6. Negative pi over 6 is right here. It's starting with our initial side and going backwards to get there. So there's negative pi over 6. Okay? If we start at negative pi over 6 and go one loop in the positive direction, we would be at 11 pi over 6. If we went another loop, we would be at 23 pi over 6. Another loop, 35 pi over 6. If we started at negative pi over 6 and went clockwise, we would be at negative 13 pi over 6. Went one more loop, negative 25 pi over 6, etc. Coterminal angles. In which quadrant does 50 pi over 3 lie? In which quadrant? Well, I could do this the long way and subtract 2 pi and keep subtracting 2 pi until this is within 0 to 2 pi. I could do that. So 50 pi over 3 minus 6 pi over 3, I'm subtracting 6 from the numerator, right? So that would be 44 pi over 3. But now I would need to take 44 pi over 3 and subtract another 2 pi. 44 pi over 3 minus 6 pi over 3 will be 38 pi over 3. Do you agree that I'm subtracting 6 from the numerators? And I'm going to keep subtracting 6 from the numerators until I know where I'm at. Until the numerator is less than 6 or equal to 6. Okay? So I'm going to keep subtracting until my numerator is less than 6. So keep subtracting 6 from the numerator. 32 pi over 3, 26 pi over 3, 20 pi over 3, keep subtracting 6, 14 pi over 3, another 6 is 8 pi over 3, another 6 would be 2 pi over 3. Okay, so 50 pi over 3 is coterminal with 2 pi over 3. What quadrant is where is 2 pi over 3? What quadrant is that in? Well, if it was 3 over 3, it would be all the way to pi, but it's not 3 over 3, it's 1 less. It's 1 pi over 3 less. So it's going to be right here. Yeah? Quadrant 2. Okay. That's kind of a long route to get there. What if it wasn't 50 pi over 3? What if it was 1,550 pi over 3? Would you want to keep subtracting 6 from that numerator? No, you wouldn't. I wouldn't either. That would be tedious. So, how can we do that? What was our process? How many times did we subtract 6 from that numerator? 1, 2, 3, 4, 5, 6, 7, 8. We subtracted 8 6s from that numerator. And we had 2 pi over 3 left over. Okay? If you take 50 and divide by 6, how many 6s are in 50? There are 8 of them, with 2 left over. The remainder is 2. That's what you want. So you're going to have a 2 pi over 3 left over. That's the quick way to get to your smallest coterminal angle. Okay? You want the remainder after you divide out your numerator. Remember, we divided out double this. You always divide out double that. Alrighty, moving right along. Next little mini topic here. Arc length of a sector. This sounds pretty different. I'm going to throw this in here today. A sector is a portion of a circle. That includes 2 sides, which are the radii of the circle, and an included or central angle. So what is shaded here in green is a sector. It is a portion of a circle. Okay? This is called an arc. Okay? So we're going to be finding the arc length. We're going to be finding the arc length. So here's how I would find the arc length. Okay? I'm looking for L. I'm looking for L. Okay? I'm going to set up a proportion. Do you agree that L is a part of the circumference? It's a part of the circumference. What is the circumference of the entire circle? I expect you to know this formula. You have to know this formula for calculus, so I'm going to make you know it for precalculus. What is the circumference of a circle? The circumference of a circle is 2 pi r. So L is to 2 pi r, 2 pi times the radius, as this theta is to the complete angle of the entire circle. What's the angle of the entire circle? And do not tell me 360 degrees. Don't tell me 360 degrees, because we're in radians. So what is it in radians? The entire circle, the interior angle is 2 pi. I'm going to solve this for L. I want to solve that for L. So I set up a proportion. Now I'm solving it for L. So I'm going to multiply both sides by 2 pi r. And look what happens when I multiply both sides by 2 pi r. I think I said L. 2 pi r. What happens? Well, the 2 pi and the 2 pi reduce out, and I get that L is equal to theta times r, or for some reason it has a better ring off the tongue if you say r theta. Theta r theta, there's something a little bit more pleasant about r theta. So this is how I remember it. However, this formula only works if theta is in radians. Theta has to be in radians. Okay? What would happen if we made that, instead of 2 pi, if we wrote that as 360 degrees? The circumference is still 2 pi r. We can't change that. This would be 360 degrees. So this time when we multiply both sides by 2 pi r, we get that L is equal to 2 pi r times theta divided by 360, right? Which would be pi r theta divided by 180. Isn't this formula easier than this formula? Yes. Radians make life easier. Okay? They make life easier. So we're going to use radians. Alright, so for a sector of radius r, central angle theta, measured in radians, the arc length L is given by r theta. But make yourself a note. Theta must be in radians. And if you forget this little formula, the derivation of it is so simple. So there's really, I personally, I don't memorize this formula. Even though it's a very easy formula to memorize, I don't memorize it. I always set that proportion up and do it when I need it. Okay? I don't like to memorize things that I can get to very easily just by deriving them. Okay, number 8. Determine the length of the arc. So we are looking for the length of the arc of a sector with radius 10 and central angle 3. So L is equal to r theta if theta is in radians. So L is equal to, the radius is 10, the central angle is pi over 3, so that would be 10 pi over 3 centimeters. If they wanted a decimal approximation, I would easily give it to them. 10 pi over 3, 10.4719. Okay? So let's think about that. If we had a central angle of pi over 3, so it would be something like that. Okay? So I can tell that my angle is not quite right. Pi over 3 is larger than I give it credit for. Okay, so if the radius is 10, this would be 10.4719 if this was a pi over 3 central angle. Okay? Alright. Determine the central angle. I changed this problem after I was making my key for the notes. Determine the central angle of a sector with radius 3 feet and arc length 9 feet. So set up your formula. Arc length is r times theta. This time I'm looking for theta. I know the radius and I know the arc length. So 9 is equal to 3 theta. So theta is equal to 3. What would be the units on that? Radians. But remember, you don't have to write the units for radians. They are assumed. So the included angle there is 3 radians. Where is 3 radians? Where is 3 radians? Almost to pi, right? Almost to pi. So if the radius is 3, this arc length would be 9. That length would be 9 there. Okay. Almost to 3, almost all the way to pi. Yeah. Did I say almost to 3? Almost to pi. Okay. That's it. 45 minutes. This was a long one. But got it all in. I think we're going to have a block day this year for this lesson, so things should be good for this block day lesson. Okay. Have fun with your assignment now.